decide your future, wouldn't it be great if you hear it straight from the top? And we know that parents and students have a lot of questions when it comes to mechanical engineering, like is it relevant or is it really for girls, or what opportunities, career opportunities do mechanical engineers have in future? And today we are breaking through all of this and we are walking through every blocks and labs where it all happens. And walking us through, and it's none other than Dr. Mahesh L, sir. Today let's begin this episode by breaking a myth that says mechanical engineering is not for girls. So, what do you have to say about this?
That is an outdated perception. Now in present scenario, it is not true. Mechanical engineering is all about design, innovate and problem solving. It is not a physical strength. Ram Kripa Ananthan played a critical role in designing of Mahindra Thar car.
Yes.
She is the leading example for an excellent design. If you take one more example, Madam Sudha Murthy is the first female candidate recruited by Tata Motors, and she later founded Infosys Foundation. If you take one more example, Priya Balasubramaniam, she is a vice president of iPhone operations at Apple. She is the best example for manufacturing industries. Finally, what I would like to say is, engineering is all about creativity, problem solving, innovation. I hope all women possess this strength, or they're having a capability to solve any problem.
That's a true myth-breaking answer. There's a lot of questions to be asked regarding mechanical engineering. Let's begin by entering to the world of mechanical engineering. My next question is, how does the collaboration with Divyashree developers actually benefit directly the students?
Yes, with the collaboration of Divyashree developers, we establish Art of Center of Excellence in the field of manufacturing technologies. Particularly, we have a Center of Excellence for two sectors of manufacturing technology. One is called Additive Manufacturing Technology and Subtractive Manufacturing Technology. Additive Manufacturing Technology involves design and development of robot, which is used for preparing the concrete blocks. And Subtractive Manufacturing Technology involves the exposure towards building CNC machines. The CNC machines are used for manufacturing the accurate products or precision products, where the students are going to have an applied learning and they will understand how the real problems solving, and we are going to give an hands-on training on writing the G code and M codes. And also we are going to have a collaborative work where the students can work as a multidisciplinary team. They can understand what is the problem of mechanical engineering, what is the problem of electronics, what is the problem of electrical, and what is the problem of civil engineering. Together, the students are going to give the solutions. So definitely students will have a capability, all this capability, so that they will be best suited for real world applications.
Okay, sir. That's insightful. Now let's walk through the block and explore more about mechanical engineering.
Yes, sure.
Mechanical engineering was once seen as a losing popularity, but today it is such a comeback. What makes this shift, sir?
Yes, this shift is due to entire world is moving back to building. It may be electric vehicle, smart manufacturing, or robotics, or sustainable engineering. All these advancements strongly depend on core mechanical principle. For example, if you take a company like Tesla, they are redefining the mobility, where it rarely depends on entire mechanical principle, like it may be mechanical design, or maybe materials, or thermal system. They are leading to the new innovation. Say from this, I can say that the field is not shrinking; it is expanding to the new horizon of innovation.
I totally agree with that, sir.
Thank you.
My next question is, many students today are mostly inclined towards artificial intelligence and data science. What would you say to someone who is unsure about choosing mechanical engineering?
So yes, it is definitely a good question. I would like to say that the mechanical engineering is not competing with this, but they are having an added advantage for mechanical engineering. The company like Siemens integrating the AI and machine learning in the field of automation and smart manufacturing. So from this, the students are having a core mechanical discipline with added advantage of AI and machine learning. The company will prefer strongly, they will recruit the students. So hence what I feel that the students of mechanical engineering, along with core mechanical principle, let us have an exposure towards AI and machine learning.
100%, sir.
Yes.
So REVA has industry collaborations like UD Trucks and Toyota. I want to know, how is this benefiting students?
So the establishment of this collaboration helps our students to apply their learning and understand the real world applications, and they will have an ability to solve the problems related to automotive engineering. It's just like having an industry, automobile industry on the campus. So this makes the students more confident to get a job opportunity. When they're attending the interview, with the confidence, they can answer the interviewer about automobile industries. Like we are having a systems called UD trucks, and for Toyota Fortuner car and Toyota Innova car, and also we're having a Volvo car engine, bus engine, where the students can have a real-time experience.
That makes sense. My next question is, mechanical engineering today is intersecting with other disciplines as well, right? So how do you encourage interdisciplinary learnings?
Yes, definitely we encourage our students to go behind their core domain, entering into the other domain by choosing the professional elective in the field of automobile engineering, in the field of sustainable engineering, in the field of smart manufacturing system. This makes the students are very competent and gain the practical knowledge. And especially, we want to educate our students how the collaborative work will be done in an industry. For example, if the student want to do in robotics, it requires a multidisciplinary domain knowledge. Hence, we are allowing the students, multiple domain students, to carry out the project so that they will understand in industry how the collaborative work will be done.
The School of Mechanical Engineering offers specializations like mechatronics, mechanical, and aerospace. How should a student decide on which path to choose?
It is a very fantastic question. Let me answer your question in our flight simulator lab. This is our flight simulator lab. All three disciplines strongly depend on core mechanical engineering. For example, the mechanical engineering focuses on design, manufacturing, thermal. It will be best suited for students who are very curious how machines are built and optimized. If you come to mechatronics, mechatronics is all about interdisciplinary. The mechatronics integrate with electronic system, control system, automation. The mechatronics branch is more suitable for students who are very curious about robotics, smart manufacturing system. If you come to aerospace engineering focuses on designing of aircraft and space vehicles. And the aerospace program is suited for students who are very much interested on high performance engineering, space vehicle design, and aircraft designs.
And I must say, the lab is so great and it will definitely inspire students.
Thank you.
And now I want to know, what are the career pathways available for mechanical engineering recent graduates?
So I definitely answer. Let us enter into flight simulator.
Sure, sir. Wow, this is so amazing. And this indeed looks like a real flight experience. This will definitely inspire students for sure.
Yes, it is. So it is the center of attraction. Anybody who comes to this REVA, by looking at this facility, they will be very jealous for about creating this kind of a facility.
Definitely, sir. With your permission, can I sit, sir?
Yes, definitely can.
Thank you. And I want to know now, what are the career pathways available for mechanical engineer recent graduates?
Yes, it is a good question. It needs to be addressed for a very newly joined student. The mechanical engineering graduates will have a career in core sectors like automotive industries, robotics industries, and the energy sector. The companies like Tata Motors, Toyota extensively hire the mechanical engineering graduates. Alternatively, the students can look about emerging sectors like smart manufacturing, robotics, aerospace engineering. The companies or organizations like ISRO, DRDO, or Capgemini, they will recruit students having this kind of a domain expert. And alternatively, they can also look into IT roles where our students have been given an experience about programming or coding, and also they can enter into a management level managerial position with the experience of financial management. They can lead into a managerial position. And also the students who complete MBA with a mechanical background, they will have an high demand in all the kinds of an industries. It can be in food industry or manufacturing industry or automotive industry or aerospace industry. Majority of the industries are driven by mechanical engineering graduates.
That definitely addresses all the confusions for someone who is excited to join mechanical engineering.
Now let us go to different venue.
Okay, sir. My next question is, do students get opportunities to work on real product designs and prototyping before they graduate?
Yes, definitely. I will take you to the product which is designed and developed by our students, which is electric car.
Okay, sir. Let's go.
This is what I was all about talking about. This is the vehicle which was designed and developed by our School of Mechanical Engineering students.
This
So
is
can-
amazingly built, sir. Can we get a ride?
So please. So with respect to projects, the students are encouraged to take up the project in second year itself. The project may be of three categories. One we are calling as a course-based project, research-based project, and finally capstone project. These are the three projects they'll execute to get a real-time experience. In course-based projects, the students, whatever they studied in the theory, they are going to convert the theory into a concept, which will make them to understand better. And one more, which will be called research-based project, where the students are undergoing a thorough literature to define a new problem. So with that experience, they will be ready to make a final engineering product.
Okay.
So final engineering project will be more on social relevance. Our students are being guided to develop the products related to robotics. They have printed a 3D printer. They have developed the electric vehicle. The one of example is what we are sitting on this one.
Yeah.
This is the electric vehicle. To build an electric vehicle, it requires a multidisciplinary team. It is not possible to build by an individual discipline. We are allowing the students to group up with different branches. Electronic students have been involved, electrical students have been involved, mechatronic students have been involved, and more importantly, our mechanical students is involved. So the result of the multidisciplinary work is an electric vehicle. So this is the work which is guided by our a good faculty team. So because of that, we got this electric vehicle. There are so many examples. Our students have built a 3D printer, robots, and automotive, two-wheeler vehicles.
This is brilliant, sir. My next question is, what do emerging technologies like AI or robotics and automation and engineering have a role in your curriculum?
The technologies, it is not only an add-on for our curriculum, they are deeply integrated into our curriculum. We are allowing the students to apply these technologies in the form of a lab or in the form of projects, and they will work on real-time application.
Okay.
Say, for example, we are introducing in the first year itself a course called Python programming, data science, and AI and ML applications. Because that, the students are able to design a project which are emerging trends, say robots or 3D printer or electric vehicle, even advanced manufacturing system, smart system, automation system. The result of implementing the AI and machine learning will yield products related with the engineering sector.
Okay, so that's also very inspiring. And before we wrap up this segment, I have a quick rapid fire questions for you, sir. One myth about mechanical engineering you want to break.
That is outdated. It is not though. The mechanical engineering is at the art of modern innovation.
Okay. Second, mechanical versus computer science, one word difference.
Physical impact versus digital impact.
Okay, sir. Third one, workshops or classrooms, where does real learn start?
Both, where active learning is going to happen.
Okay, sir. One skill every mechanical engineer should have.
And a problem solving skill.
Okay. Core or non-core, what matters more?
It's not a matter, it is a skill.
Okay. One misconception parents still have about mechanical engineering.
Low career opportunities, but opportunities are unlimited.
True, sir. One habit that separates a good mechanical engineer from a great one.
Curiosity about how things are working.
One quick advice to a student choosing mechanical engineering.
Be ready to make your hand dirty and make your mind sharpener.
Okay, sir. Thank you.